Today I want to share a really simple dependency confusion vulnerability discovered by Giraffe Security. The title of the article is Hat Trick. AWS introduced the same RCE vulnerability 3 times in 4 years. So in 2022, Giraffe Security discovered this vulnerability in Amazon's Neuron SDK, which is a set of Python libraries for running machine learning workloads on specialized AWS hardware. The issue is not in the libraries themselves, but rather how Amazon instructs users to install this package. In many tutorials and even the official documentation, for which there's a link, Amazon instructs their users to install their packages with a command that looks like this: pip install package name, this extra index URL parameter, and then the repository where the package is held. Now this command may look innocent. We want pip to install the package, in this case Transformers Neuron X, and we want it to be downloaded from the PyPy index hosted on this host instead of the default index. But it is not actually as simple as it seems, which we'll dive into here in the bug section. They found this kind of bug previously in other places. Python's pip package manager has some quirks that make it difficult to install packages from private registries correctly. Very often people discover the extra index URL parameter and use it as the way to install the package from some other package registry. The parameter works, but it has a corner case. I wonder if you've picked it out if you've been reading the name of the parameter carefully. It does not guarantee that the package is downloaded from the specified index, and pip may also download the package from the PyPy default registry. Can you see that? They've named it extra index, and that kind of gives us a clue in the sense that it goes looking in the default PyPy index first, and then if it can't find it, it goes looking in this extra index URL. This is a problem if you are distributing packages that are not uploaded to the PyPy default index, but only your private index, because of course it searches the default index first, as then the malicious actor could upload the package with the same name to the default index, making pip download the malicious package first and then use it upon installation. This can lead to remote code execution when the malicious package is loaded. They've discovered this exact issue back in 2022 when Amazon was uploading their packages here, but they did not upload the same packages to PyPy. So obviously Amazon made this mistake, making these packages up for grabs for anyone on the internet. We ended up claiming a few of these packages and reported the issue through their bug bounty program. They then promptly fixed the issue by uploading dummy packages. Amazing. Well, there might be some evidence that this mistake had happened before. The researcher noticed that I had not been the first one to notice the problem, as I found that some of the Neuron SDK packages in PyPy had an interesting version history. Below are some images from libraries.io. Libraries.io is a tool that scrapes data from open source. A large set of versions of the package Torch Neuron, one of the libraries in the SDK, were published in 2020. All of these versions were uploaded at the same time and had such variety in version numbers that it leads them to believe that someone was doing this maliciously. So it uploaded to the default registry rather than the private registry. Based on this information, they suggest that Amazon was aware of the issue in 2020 and had fixed it. They then also say that they expect that after closing their report and fixing it, they would have figured out a systematic way to set up a process to claim these kind of new package names in the default PyPy registry before publishing it in their own private registry. Turns out that's a bad assumption. In December 2024, I happened to visit the Neuron SDK private package index again. So that's this one here that you can just navigate to. There's a link from the article. And they observed that they had expanded the set of packages quite a bit. So it wasn't just the old set, but they had added new ones. Out of curiosity, they obviously tried this attack again and see if all of the new packages had that dummy package installed on the default PyPy registry. And they found that they weren't installed. So then they had to file a similar report to Amazon to inform them of the vulnerability that it had cropped up against. To recap, they believed they had introduced this same dependency confusion issue on 3 separate occasions. While it's impossible to guard against all possible attacks, it is interesting to see Amazon is repeating the same mistake over and over here. Usually large companies like Amazon take security seriously, so I was wondering what exactly has happened here that they have dropped the ball 3 times in a row. Look, I'm not going to speculate as to what happened, but this kind of issue, like I have observed myself happening a lot. It's very hard to keep these bespoke kind of tests running over time. You'd love to see a systematic process being implemented, but I can see how this could happen. Teams turn around pretty quickly. There's new team members. There's new ways of developing things. Things get lost. So I can see how this has happened. Luckily, the researcher reported the problem multiple times, and Amazon is obviously fixing the issues. I'm sure sure they will have a systematic fix going forward. But I don't think it's as bad as the writer makes it out to be. On the other hand, the Neuron SDK team could be treating this as a configuration mistake made by the customer, as technically a knowledgeable customer should know the dangers of the extra index URL and should install the Neuron SDK in the same way, for example, using the index URL parameter instead of the extra index URL. Or they may not consider this a problem at all, as documentation and tutorials are just guidelines for the customer, and the customer is ultimately responsible for keeping the application secure, no matter what the Amazon documentation tells them there. I think this is a really interesting part of the post, in that the shared responsibility model comes into play. If Amazon is publishing slightly incorrect instructions and that leads to a customer misusing their own infrastructure in some way, that's kind of gets a little bit murky. Obviously, they should provide the most secure possible ways to install things. And I believe they do fix these kinds of issues pretty quickly. I think the lesson of the story is not to assume that code on the internet is secure. Good lesson, I guess. Even if it comes from a reputable source like AWS documentation. Always familiarize yourself with everything before using it in production. Many people, we don't have time to understand how to use every package manager, every CLI with the exact parameters, etc. I think the real fix here is just to provide more secure instructions on installing these, and for AWS to have a systematic process to claim these packages on the default registry, so that in case someone accidentally uses the wrong parameter, they'll still be safe. As usual, if you have any comments about this article, contact Giraffe Security. If you want to contact Giraffe Security, they do have a Twitter account, although it doesn't have any posts and doesn't follow many things, but you can check them out at Giraffe Security. Thanks.